Okay, so next example for calculating wavelength and frequency for electromagnetic radiation, remembering that the velocity is always going to be a constant when we are calculating with electromagnetic radiation. So first we do our drawing. Well, let's read the question. Calculate the frequency of yellow light in a vacuum. The wavelength of yellow light is 410 times 10 to the minus 9 meters. So we're going to draw our drawing. We're going to label it 410 times 10 to the minus 9 meters is our wavelength. And then we're going to list our known variables. So we know that the wavelength is 410 times 10 to the minus 9. Notice that I'm not going to change this to proper scientific notation. And there's a reason why it's listed at 410 times 10 to the minus 9. 10 to the minus 9 is a nanometer, and it is 410 nanometers. And so when we're looking at the different wavelengths of visible light, we often refer to them in the nanometers. And so 410 is the number. And so we just know that times 10 to the minus 9 is a nanometer, but we need to be working in meters in order to cross cancel. So we're leaving it in meters. So we don't need to bother to change this into proper scientific notation now because we're going to do it later. Okay, and our constant is velocity at 3 times 10 to the 8 meters per second, which leaves us solving for frequency, which is our unknown variable. Okay, so the next step is going to be to write out the formula that we're going to be using, and we're calculating, we're solving for F, so we can cover up the F in our triangle. And that means that we're solving for velocity over wavelength. So give myself a little bit more room. Frequency is equal to velocity over wavelength. Now I plug in my known variables. So I know that my velocity is 3 times 10 to the 8 meters per second. Remember, we're always showing units. No naked numbers are allowed. Over 410 times 10 to the minus 9 meters. Okay, so now let's take a look at what happens next. So first we're going to do the division of just our numbers up front so that we have some values to work with. So I'm going to slide over a bit. Frequency is equal to 0.32. Take that back with me. Frequency is equal to 0.007310707. And then we also have to calculate the next thing, which is going to be our exponents. So we're going to take a look at the exponents we have, and it's 8, and we subtract minus a minus 9. So 8 minus a minus 9 is going to be adding, so it's going to be times 10 to the 17. And then we're going to look at our exponents. Our S gets to come to the bottom. Our meters cross cancel, and if we have a per second, that's going to give us a unit of hertz. Sorry, we're running out of room. Let me give us a little bit more room. Oh, pencil, that would help. Okay, so now that we have our actual answer, it's not quite correct. We have to turn this into proper scientific notation. So we need to basically move our decimal, which lives right here, over so that there's only one value in the whole number position, right? And so we're moving it over 3 times. And we have an exponent already in this number. It's 17. And we're moving our decimal over 1, 2, 3 times. So we need to take 3 away from our exponent to do proper scientific notation. So our answer is going to be 7.31707 times 10 to the 14 hertz. And that is our correct answer with its units.